Truth out of reach. That is a something is true, but we not get it yet. So this is I culture. So business standard today is 17. Let's we begin with the new and editorial, and that is truth out of reach. So just begin it. I am at all events convinced that God does not play dice. That is about all the event convinced that as we know that the God has not played the dice. With that, Albert Einstein voiced that unease inherent randomness at the core of quantum mechanism. He preferred a universe whose working unhidden but ultimately knowable. But what if the working the universe is going on, but is unhidden that we cannot see, but it's ultimately knowable because we know that what is true and what is the lesson that we know all about. So we know the randomness and the knowable the things. So that is the randomness and that's the things that we wanted to. So randomness resists such a comfort with toss coin, like with toss coin, shuffles card, such kind of the activities we are going to do. Pick names from heads, yet much of its illusions. We know that's kind of the illusion we don't know about it beneath that we call random lies hidden clockwork. You know all the activities clockwork. We know the when the random is still sometimes is wrong and sometimes is true. Still, from cryptography to climate models, like any kind of the cryptography or the formulas or the climate models, like when the rain is going to happen, this kind of the activities predicted by the rain climates. The hunt for the true randomness remain one of the science most urgent quest because the science wants to know why does it something is happen with anyone, like randomness or anything. Why does it happen with the urgent quest of the persons. So this kind of the activity still the science wants to know. And then it's the core randomness is the absence of the pattern. And in the theory it's simple. Flip a coin, you know, you toss a coin like head or tails in India. In practice, universe show its habits. You know, universe shows what the habits are all the way, and followed the mechanism enough data on a weight air currents, like we know the air currents are like air currents, the things that we know. And air currents and we try to know, be predicted, and possibilities we try to know. And things are happen with us like randomness, flip a coin, and all the activity that we are going to do. And still, and heads or tails should be predicted. Here deterministic, probabilistic, and truly random system diverse because it's a code and we don't know what to do. The coins which happen with every single day, but it's unknowingly probabilistic. You know, the things are the very probabilistic, like still we don't know the things like how is it going. Truly random system and divergence, you know. Deterministic system leave nothing to chance. System leave nothing, you know. Deterministics, like we determine something that's happened something else, giving initial conditions. The outcome is inevitable because it's happens because that is like inevitable. So that is outcome is inevitable because the outcome has come. So if we don't or we don't know, like, but outcome is still comes with us, like we know that outcome is come. And we have to deal with that. And for example, appear unpredictable from sometimes from ignorance from starting deals, like unpredictable. Why? Because lot of activities and lot of things are we know like unpredictable, we don't know. Often some ignorance is starting details. Probabilistic system embrace uncertainty. You know, this is a great line that probabilistic systems are completely uncertain. We don't know what is happens with that because uncertain, unpredictable, or active probabilistic, like probable it's going to happen. The deal in the likelihood not certain because the things are not certain. A die has 1 in 6 chance of showing each faces, has a chance. But you know, the always as a dice, we know from the very long time that we know that as a die has a 1 is a, and the 6 chance of each face it has a come. But we are not true that will come or not. But probability theory can't tell which will appear in next. You know, this is the one of the things that the probabilistic theory says, like we actually we don't know what the probability will come. Theory can't tell ki appear what the appear next. We don't know the what the appear coming to the next. And we guess that it's true. Weather forecasts speak in chance because countless variables make prices predictions impractical. So that's why the any formulas are not available. So we can't predict what is going to. There is a impractical to predict what happened the next. truly random systems, predictions impracticable. This is a very important thought, that the predictions that is a impractical, so we don't know idea what is going to the next. Truly random systems are rare, unpredictable system, not from missing data, from the absence of underlying determinisms. Like we cannot determine missing data, because many of these ideas are happening that, so we don't know that, because the missing data are the one of the most things that with the absence, missing data are the absence in the determinisms to determine something that is a true or right or not. So that is the absence of that idea to how to save that. So quantum mechanism shattered centers clockwork thinking, or like people thinking that is the centuries of the clockwork thinking, like we identify the predictions of the data or something. So that's, we decided that the clockwork, the clockwork thinking system is going wrong. Subatomic practicals behave in a way classic physical cannot predict. Physics cannot be predict behave in a ways it cannot. Photon hitting a beam splitter has 50% chance of taking either path. Photon hitting a beam splitter, and it's a kind of example they're giving. It's a 50-50 chance of something. No hidden measurements can reveal the outcome in advance, because no event, no hidden measurement. It's a no measurement outcome in advance that we can say that is going to happen. Human limitation, it's a nature rule book, because someone has a human limitation, because a human cannot predict each and every single activities. Human limitations, like something like human cannot do that. That's a nature rule book. Nature has just decided that. Quantum randomness has real world uses, like cryptography depend on the unpredictability. Cryptography encryptions key must be impossible to guess, and a key must be impossible to guess. Inscription key must be impossible to guess. We cannot guess what is the methods. Per so random number generations are good, for example, but dangerous for the security unless seeded with the real unpredictability. The pseudo random number generators are good for the games. Pseudo numbers, like randomly the numbers has appears, and dangerously for the security point of the view. What is the dangers for the security point of the view? Your secrets are revealed in, and you secret in pseudo randoms number generators, and can reverse engineered. It could be the reverse engineered. It could be like, it can be good for us, but at the same time it could be a bait for us in on some extent. True random number generator take advantage of their inherent predictability. Quantum image by drawing inspirations from natural occurrence, like radioactive decay, like inspiration from natural occurrence. The natural, like anything is happen, like we natural, anything radioactive things that happen, like we naturally occurrences we took as a delay. That's a good way to them. Quantum computing pushes this further. It's a pushes ahead and further, that quantum computing, like is a theory. Quantum q distribution is uncertain, pushes further. It pushes further. And quantum key distribution uncertain as a security feature. It's still, it's there some security feature is that is a uncertain, still is uncertain. We don't know, unpredictable, uncertain, not sure about what is happening into the future. And interpreting a quantum encrypted message disturb the system, exposing the ends dropper. Future computer will not remove the randomness but harshness it. Future computer will gonna do that, some kind of the advanced technology or something, but it not completely remove it, but it is a harness it. It could be improved in that future sense, but it is not that completely remove it though. And we need to be guess here, like a recent milestone. It's some achievement. Milestone is achievement. Potentially nature research from the JP Morgan Chase. JP Morgan is the it's the investment ideas giving a working in that is a quantum ergon and national laboratories and University of the Texas in the USA. Texas Austin reported the first certificate randomness expansion protocol on the quantum computer. In that research from the JP Morgan, they decided that the University Texas and Austin reported the first randomness expansion. Okay, it is going to be expand. It is going to be predictable. How we can predictable. So in Texas, the research JP Morgans and all kind of the researcher Chase and randomness expansion protocol quantum computer. So it's a achievement for some of the people that we're gonna say, like it's protocol, like it's going to be working. Random circuit sampling, like using random sampling circuit using used produced more randomness that they took as input, something classic mechanic cannot, it cannot be happen. and do the digital world apart from the randomness is worse. Randomness powers Monte Carlo simultaneous and algorithm that rely on repeated random sampling to obtain numerical reason in finance and physics. In finance world and in physics world and in finance world, we use a lot about this. Why we gonna use it? Because it's in finance and physics are its use is a lot. And in finance and physics is used a lot. Finance and physics helps AI explore solutions. It helps AI and explore solutions without any it's a very important for the human poor randomness. It's a very like where we can work as naive algorithm. So this is working like gambling theoretical without poker, shuffle predictable, and generating and true randomness is hard. Humans are poor randomness. Humans cannot be, but computers do. When faking coin toys, we avoid long runs and insert patterns. Computers feel little better. Naive algorithm can produce telltale repetitions. The telltale what we can once twice. So algorithm do that. Einstein dice planning god is Einstein says it's god wishes or god was doing like that kind of the activity. It was his voice like Einstein, a big name from the physics industries and from the science and technology, hopping Indian variables under like quantum uncertainty. But decades of experiment, notably Bell theorem test, that eroded that view, and it has changed the view. It's completely it's theorem that completely eroded the view. Bell tested have constantly found that physical system obey quantum mechanism. This is a system that quantum mechanism it follows, and the stakes are rising. The stakes are rising, and what we're gonna do? The stakes are rising. The Internet of Thing will connect countless device. It's connect countless device. It's connected and sensitive data, countless data, connected data, quantum computers existing, encryption enabling new quantum randomness based scheme. Learning is real random process that can be wipe out the random fled beyond the technological randomness sees into art and policies. We can beyond technology randomness steps into the art and tech policies. We can see in the art policies and lot any activities we can see that rely and process rep and flowed beyond technological. We will use that artists feed random generators into creative tools to produce music, literatures, and surprise but them. It is a produce music and literature that surprise even them. Yeah. Policies, scientists random missing sampling to avoid bias for all engineering skills. This is a very good way to deal with that, and all are the that is a random, and that's a conclusions, and conclusions is all about there is a conclusion for all engineering skills. True random retain almost mystical quality. Engineering skills is completely random, but the true and genuine for the point of a very of a lot, and remind that all thing can be tamed. Chaos theory show how to deterministic can help unpredictable. It's predictions and mystical tracking and deterministically remind us not all things can be tamed. All things can be reminders. It cannot be all things can be tamed, and uncertain principle ensures some truth are forever out of reach. There's a great line that is a that's tell about we need to understand that some truth are forever, and it's always be forever out of the reach. So that's for today for the business standard. Let's meet tomorrow, and any of the guys who want to click a picture that we can take that, and this is for today. Thank you.